Guys, this is an introduction to right triangle trig. I know we did it in class last Wednesday, so hopefully you have some notes on that. But if you were out or have forgotten that stuff, I just wanted to go over it so you can do your homework for today. Um, with right triangle trig, and especially in geometry, we're going to focus in on three trig ratios: the sine, the cosine, and the tangent. Now, we just finished a unit on ratios, and you guys solved proportions and things like that. So all of that we learned in Chapter 7 should be real applicable to what we learn in this chapter, because the sine is just the ratio of the opposite leg of a right triangle. All of these have to be in right triangles, so that's why we talked about Pythagorean theorem and the 45, 45, 90, and 30, 60, 90 right triangles. These all have to be for right triangles. But the sine, and this is the abbreviation for sine, is the ratio of the opposite leg divided by the hypotenuse, and we'll talk about what those words mean in a minute. The cosine is the adjacent leg divided by the hypotenuse, and the tangent is the opposite leg divided by the adjacent leg. As always, that says, okay, X out of that. Okay, so sometimes it's easier to remember SOHCAHTOA. It's just a little phrase to help you remember. The sine is the opposite leg over the hypotenuse. The cosine is the adjacent leg over the hypotenuse, and the tangent is the opposite leg over the adjacent leg. You're going to be given a right triangle, and one of the angles will have to be a right angle. You're never going to be finding the sine or the cosine or the tangent of that right angle. It's going to be one of the other two angles, the other two acute angles. So let's say I were talking about angle A, and this was going to be the angle that I was going to use. And let's put some lengths on these sides. Let's say this side's 6, and this side's 8, and this side's 10. That makes a right triangle. We can check it with Pythagorean theorem. 6 squared plus 8 squared, does it equal 10 squared? 6 squared is 36 plus 64. 10 squared is 100, and 36 plus 64 is 100. So this is a right triangle for sure. So if I'm at angle A, and this is the angle that I'm using, sometimes they'll use this little mark to show you which angle. It's called theta. It just stands for, I'm talking about this angle. That's what it's telling you. You got to pick out first which side's the hypotenuse. Well, hypotenuse is always the longest side, and it's always across from the right angle. So the 10 is the hypotenuse. If I'm talking about angle A, then 6 would be the opposite leg. These other two are legs. This is the hypotenuse. These are two legs. One of the legs is opposite the angle you're talking about. So if I'm talking about angle A, 6 is the opposite leg, and 8 is the adjacent leg. We said adjacent means next to. It's the leg that's right next to the angle, and it connects your angle to the right angle. So that's the adjacent leg. So if I wanted to find the sine of A, I would want the ratio that expresses the opposite leg over the hypotenuse. So the opposite leg is 6, so that's the top of my ratio. The hypotenuse is 10, so my ratio for the sine of A is 6 over 10. If you can reduce it, you want to do that. So 6/10 can reduce. 2 goes in the top 3 times, and 2 goes in the bottom 5 times. So the sine of A is equal to 3/5. The cosine of A, cosine is going to be from A, cosine is the adjacent leg divided by the hypotenuse. So if I'm at angle A, the adjacent leg is 8, so that goes on the top of my ratio. See, adjacent's on the top, hypotenuse is on the bottom, so it's 8 over 10, and 8 over 10 reduces to, let's see, 2 goes in the top and the bottom. 8 divided by 2 is 4, and 10 divided by 2 is 5, so the cosine of A is 4/5. And the tangent of A, tangent is the opposite leg divided by the adjacent leg. So if I'm talking about angle A, the opposite leg is 6, the adjacent leg is 8. So 6 goes on the top of the fraction, 8 goes on the bottom. 6/8 reduces to, they have a common factor of 2. 6 divided by 2 is 3, 8 divided by 2 is 4, 6/8 reduces to 3/4. So the tangent of A is 3/4. What if I were talking about angle C? Let me do a little bit of erasing here. I can not mess too much up. If I'm talking about angle C, I'm going to keep the same side lengths, the 6 and the 8 and the 10. But it's going to change which side. The hypotenuse is not going to change. It's still going to be there. But instead of this side being the opposite and this side being the adjacent, it's going to flip. See if I can erase that little mark right there. Okay. So draw the triangle back. Now instead of talking about angle A, Sorry about that. I'm talking about angle C. So this is my angle that I'm dealing with now. So if I'm talking about C, 10 is still the hypotenuse, but the opposite leg is going to be over here. This is going to be the opposite leg from C. And from C, this is going to be the adjacent leg. So the sine of C is the opposite leg divided by the hypotenuse. So from C, this would be 8 would be the opposite leg and 10 would be the hypotenuse. 8 over 10, which reduces, we already reduced it in the previous problem, to 4/5. The sine of C is 4/5. The cosine of C would be the adjacent divided by the hypotenuse, which is going to be 6/10, which reduces to 3/5. And the tangent of C is the opposite leg over the adjacent leg, which is going to be 8/6, which reduces to 4/3. So those are my answers for the sine of C, the cosine of C, and the tangent of C. And your problems today are just going to have some different sides on them. It's just going to be a random triangle drawn out, something like this. They may say something like X, Y, Z. Let me put some links on here that I know work out. Let's do 5, 12, 13. That's a right triangle. I'm not even going to check it. You can trust me on that one. It might say, what is the sine of X? Or it might say, what is the tangent of Z? Well, the sine is the opposite leg over the hypotenuse. So if I'm at angle X, the opposite leg would be 5. The hypotenuse, which is your longest side, is 13. So the sine of X is 5 over 13, and that doesn't reduce. Nothing goes into 5 and 13. The tangent is the opposite leg over the adjacent leg. So if I'm at Z, the tangent of Z, the opposite leg from Z is going to be 12, and the adjacent is going to be 5. So it'd be 12 over 5. And that would be how I would answer those types of questions. So you've got 20 to try tonight. So good luck. Let me know. Message me if you have any questions.